All right, good afternoon, folks. I am Eric. Welcome to Bypass 101, a talk about all the ways to get around doors that don't involve picking the lock. I've been with Bypass Village, now Physical Security Village, since 2019 when we started. I have a job. This is not my job. I write high-performance trading software for capital markets. Views are my own. Opinions do not represent my employer. You all know the drill. We've been on the conference circuit for a couple years now. We have some demos in the village area. My hope is that you learn these skills here. You know, you go home, you apply the remediations, but you also come to a village, try them out by hand. So we're all the ways to get around locks. Lock pick village is picking locks. We're not that. I'm a simple and impatient kind of person with really bad fine motor skills, so I'm going to keep it simple here. While the basics of using doors are understood by many, we're going to talk about several advanced door manipulation techniques that will allow you to take your door using game to a whole new level. We're going to talk a lot about lateral thinking. Let's take a look at one particular example I really enjoy. Is that the right direction? Yeah, I can't see the screen. I think it's playing, right? Give me a thumbs up. Yeah. So, door's locked. You know, maybe we see some way around the door, like a mailbox. Yeah. Cool stuff. It's not always going to be that simple, but sometimes it is. Don't stop believing. Let's think about for a moment about our model of a door, right? What are the core functionalities that a door needs to be able to perform? You need to be able to open it. You need to be able to close it, ideally without manipulating it as you're closing. It's got some moving parts, hinges, locks, and things that drive them, latches, handles, and each of these play a role. The door needs to remain shut when it is closed, needs to be able to close on its own, which, you know, it's an interesting engineering problem. How did the engineers of yore solve that problem? They do it with a latch. So if you look at the door, there's this member that's kind of on an angle, and it has a lever arm that as the door is closing, that latch slides in, allows the door to slide into the frame. Likewise, a commercial model is closer to what you'd see on the right. So that's what we're attacking, you know, when we're talking about attacking the latch. But the engineers were smart, right? They foresaw that someone might come in, try and slide the latch in, pull the door open. So there's a second moving element there, you see, the dead latch, the little kind of half moon one right next to the other latch. When door's properly installed, that will actually be depressed when the door is in the frame. On the one on the right, it's that second moving element below the main latch. But thankfully, and like in lockpicking, we're exploiting the fact that oftentimes these things are not installed properly, right? We're exploiting tolerances and variances in manufacturing and installation. And if you've ever installed a door, you know, like, it's a real pain, right? Those tolerances easily add up. You know, here on the left, we've got a strike plate where the moving element on the commercial door is just going to be fully extended, right? It's not going to be engaged. The strike plates on the right, you see there's nowhere to catch that dead latch. So, you know, if it's like that in the door, you can come in and with a tool, push the latch in, right? Allow you to slide the door open. It's dead simple. Again, you know, don't stop believing. Every so often it does come up. If you find that the dead latch is properly engaged in the strike plate, sometimes if you give the door a little jiggle, it'll give it just enough give. Door slides in, dead latch pops out. Now all of a sudden you can come in, move that moving element back into the door, pull the door open. What can you do that with? Little piece of sheet metal is great. Maybe even a piece of wire. Butter knife works if that's all you've got. Right? These are pretty crude, simple attacks. There's the old credit card trick if you're coming from the other direction. If you've got a nice, flexible piece of plastic, you can come in from kind of the side of the door that it swings away from, slide it through the door jamb. In this case, the room keys from the Flamingo at DEF CON, I want to say it was 2019, worked really well for this. what does it come down to? You want to stop these attacks. It's about doing what the engineers intended and actually installing your door properly. It's easier said than done. And realistically, if you look around your workplace, look around your home, you're probably going to see, these vulnerabilities present. How do you deal with that? You could use something like a latch guard, right? You've probably seen these pieces of metal around the handle. That's there to stop someone from being able to come in with a little piece of sheet metal, get in, under behind the latch, pop it open. It's not ideal, right? If you have a long sheet metal element tool that you can get in and slide it open, that still works, but it's better than nothing. So, going back to our model of a door, what it needs to be able to do. Door needs to be able to close itself, right? And that's the vulnerability that we exploited when we're talking about the latch attacks, right? But someone also needs to be able to, from the secure side of the door, use a handle and get out to open the door. Oftentimes, fire code requires that the handle be able to independently operate any of the other locking mechanisms unless there's a deadbolt, right? So that in case of a fire, some other emergency, you can easily egress the building. So the handle has to be able to open the door. So what we're trying to do when we're targeting the handle is emulate somebody exiting the door from the other side. How can we do that? We've got a good demo in the village as well, and some pictures here. If you can, either under the door or beside the door or even above the door, get a piece of wire around, hook it up onto the door handle, apply downwards force, easier said than done without deforming the wire out of shape, that mimics somebody pushing the handle down, opening the door from the other side. You'll want about a 5-foot-long piece of wire, ideally with the string tied to the end that you're going to send under the door. That's so that once you have it hooked, you can easily apply like downwards force with the string rather than just pulling the wire right into the door. As mentioned before, this method works with doors with lever-type handles, and you need enough room either under or beside the door to fit the tool. All right, so it comes back to variances. You'll also notice, and in the demo that we've got in the village, some handles are easier to attack than others. So if there's a hook on the end, it's really easy to get the wire in there and keep it engaged as you're pulling. Like the one we have in the village, it's like a flat handle, so as you're pulling the wire down, it tends to slide off, which is a big pain, but probably good on the security side if you're the blue team. Doorknobs, much less common now, in part because of fire code. If you don't have full dexterity in your fingers, it's really difficult to operate a doorknob, so we tend to not see them too often anymore. Great for pen testing, that they aren't common anymore. To get around this, it's quite cumbersome. You need, again, a wire to guide a ideally pretty friction-heavy piece of rope around the doorknob, and then pull that rope to kind of emulate, again, someone pulling the door handle open. Occasionally see this in residential installations. Again, not so common in commercial and industrial, some institutional, thinking about like older university buildings maybe. Crash bars, not to be confused with push bars, often seen more in commercial installations. They're relatively simple in concept. In case of an emergency, you can press without needing to fumble with a handle, or if there's a crowd crush, pushing up against, that crash bar will open the door. How to, open this type of door? Again, you're trying to emulate someone pushing on it. So using a piece of wire and string, getting underneath the bottom of the door, provided there's space, hooking up onto the handle and then pulling downwards force, pulling the handle into the door, causing the latch to disengage, allowing the door to swing open. Pictures here. So again, about a 5-foot-long piece of wire coming from under the door, traveling up, hooking onto the handle, and at that point, pulling the crash bar into the door, allowing the door to open. how do we protect against this? Ideally there wouldn't be enough space for a wire to travel under the door, but failing that, there are remediations, right? A fitted bevel on the door threshold prevents bypass tools from being able to fit through the gap underneath the floor. Alternatively, rubber door seals or brushes under the door make it immensely more difficult to execute this type of attack. Also, let's think realistically, it's quite cumbersome to get a wire there, which means that, if you're the red team in this situation, you'd likely be lying on the ground of a hallway, in a commercial building, fumbling with a tool, which will probably alert folks to the fact that there's something not quite right going on. Push bars are much more common, in part now because of how easily exploitable the old crash bars were. There's nothing really to hook onto here. Often the best bypass for a push bar is targeting the latch, like we saw earlier with the door handle. An alternative method is using a piece of string if you have access to above and below the push bar, like you might see in some high security fencing even. Finessing the string over the push bar through a hole at the lower end, grabbing both sides and pulling. How can you remediate this? One approach is to use a magnetic lock at the top of the door. We have an example in the village as well. Some meta remediation, how do you attack this? Either by going after the power supply, these unlock when there's a loss of power so that they don't trap you in the building when there's a power outage. So you want to ensure that the power supply is on the secure side of the door. Deadbolts are much trickier to bypass. They're different from dead latches. They remain fully engaged, fully locked, or fully unlocked. Oftentimes on the secure side, there'll be a thumb turn to allow you to unlock it without needing the key on the secure side. One way to attack this is by using we've got an example in the village as well, a tool that comes in through the door and it's like kind of one of those angled drills, right? If you can imagine it, where you turn a wire and then it turns a handle on the other side. Get that around the door, hook the handle on, turn on the unsecure side to open the deadbolt. One remediation against that is using a double-sided deadbolt where there's a lock on both sides. Again, the issue with that is you run into fire code issues. You could potentially have someone locked on the secure side of the door and being unable to egress. Think about lateral attacks against doors. Sometimes you can just pull really hard. It's not a joke. Not all doors are pullable, but a surprising number of them have just enough flex in the frame. Either if it's metal and it's a hot summer day, or it's wood and flexed over time. If you, for example, ever moved lumber between Toronto and Las Vegas for a demo, you find the wood flexes quite a bit. Again, seasonal variation causes doors to flex. It might mean that pulling really hard on the door is just enough that the latch ceases to engage. The skill that you need for this is just brute strength. I flew down here yesterday with 3 model doors in a single suitcase, 70 pounds. So, I started working on that yesterday. General technique, pull really hard. Does it work? No. Pull harder. Go to the gym. So again, think back to our model of the door. We've talked about the latch. We've talked about the handle. What else is left? The hinges. If you can remove the hinge, you can allow the door to open in the direction it wasn't intended, right? Open about the other angular direction. Sometimes the easiest way to unlock the door is, again, not to unlock it at all. If the hinges are installed on the unsecure side and you can access the hinges, you can either tap out the hinge, or in this case, if the hinge is fully installed on the wrong side of the door, maybe you can get a screwdriver in, just remove the hinge, take the door right off. So when you're looking at the door, you want to look, probably along the frame try and see if you can identify the hinge. Sometimes on commercial installations, like the example here, it's near the top and bottom of the door, right? So likewise, if you remove those, maybe you can take the door straight off the frame. Screwdriver. Probably won't see this in real life. Hopefully, it's quite egregious. It happens sometimes. An alternative, this you might see more often, especially if the door is opening outwards, right? So that you can't kick it in. You want the door to swing outwards towards the outside. This often also means that the hinge is exposed to the public. You know, screwdriver and hammer, tap out the hinge, take the door right off. You know, it seems pretty bleak when you look at it this way, but there are remediations. One approach is to use a set screw in the hinge so that when the door is closed and that you can't get to the set screw then, it doesn't allow the pin in the hinge to slide out, so you can't tap it out anymore. Another approach is to, like on the right, use a hinge with a stud hole that prevent the two parts of the hinge from being slid apart if the hinge is removed, right? So in this case, even if you can tap out that pin, you can't take the door out of the frame because those studs are still engaged. As it's engaged on both sides of the door, you can't pull it out. This is a relatively cost-effective remediation, especially if you've got hinges exposed on the unsecure outside side of the door, which you probably do. Right? I mean, even look at those doors, right? They're exposed hallway side. If this was a secure site, maybe you can take the hinges off those doors. Now I know if any of those doors go missing, I'm probably going to get blamed for it. So, looking at other ways to get through a door, maybe there are keys nearby, or maybe it's a lock with a combination. Oftentimes, you might see these around a building, right? Holding a bunch of other keys. And I think I have the slides misarranged. Yeah, oftentimes, you know, they get worn down because they're painted on the pin pad. You see which buttons have been pressed. It reduces the solution space that you then need to brute force. They also have defaults. The simplex default is, I think it's 2 and 4 together and then 3. There's a helpful sign on the door. Bottom line there, change your combinations. One other approach is if it's a pin pad on a door, using some UV ink applied to the buttons allows you to figure out which buttons are pressed more often, which is probably the ones that someone has been keying in to get into the site. Depending on the UV ink or powder you're used, it's also possible for that pigment to then transfer from one button to another when someone's using the lock, allowing you to see the sequence. One remediation for this is scramble pads that you might see in real high security facilities, where you press a button that then there are like LEDs in each of the buttons on the pin pad that get shuffled around so that it's not going to be the same arrangement of buttons each time. That's a relatively high-cost remediation, though. Enter phones. You often see these on the outside of apartment buildings to allow, you know, your visitors in so that you don't have to come down and get them each time. There are master codes often on these that can be found online. Bottom line there is make sure you change your default passwords. Also, oftentimes these are locked, so you can't get into the internals, but these locks are key-to-like. There's really no reason for you to use the key-to-like enter phone key. They can be changed. If you can use that key-to-like key to get behind the enter phone panel, you can likely identify which jumper is used to unlock the door. I think that's up. Cool. Which is the set of pins that go to high when the like 9 DTMF tone is received, that then allow you to allow the door to open. So if you can identify that, jumper that, once you're into the enter phone panel, you can get in. See, does that bring back up the slides? Cool. Remediation for this, you can put a security bar on the front of the enter phone, locked separately, or just change the lock. Rec sensors. You're on the secure side, you want to get out. Oftentimes there'll be IR sensors above the door that then unlock the door. They rely on passive infrared, so they're looking for changes in heat, generally body heat, but it also means that if you have something that can generate a lot of cold, generate a big thermal difference, that also trips the enter phone, allows the door to open. Remediation for this, either pass back, like tap your pass to get out, or have a request to exit button next to the door. There are also some dual technology rec sensors that use both passive IR and radar to identify if there's actually someone on the secure side. They're pretty cool. They're more expensive though. You want to be careful though that your request to exit sensor isn't quite too close to the gap in the door. We've also got an example in the village where you can come through and using a tool, tap the request to exit button, opens the door. My office has this exact issue as well, if you were so inclined. Please don't look up where I work. Or you could just straight up avoid the doors altogether. Elevators, very common in modern buildings. Oftentimes there'll be floors in the elevator that are locked out. So you need either a key card to get to, or the elevator will just not take you there. Luckily, there are ways to bypass these and get to the locked out floors through elevator hacking. I won't get into that now, except to say that it is possible, either through putting the elevator into attendant mode, fire mode, gaining access to the hoistway, elevator surfing to the floor in inspection mode. Right? These are modes that generally bypass any lockouts on the elevator. What do you want to do? You can generally switch out most of the common service locks on elevators. However, the fire locks cannot be changed. What you can do is not rely on elevator lockouts for security. So where you do have a secure floor, don't assume that the lockout on the elevator is going to keep that floor secure. You want to have a door on that floor as well, which is secure, after the elevator to stop someone from being able to access the rest of the floor. And hey, sometimes doors are just left propped open, either human error, a warped door frame, air pressure differentials, especially, thinking about scientific buildings where there is higher pressure on one side or the other that prevents the door from fully closing. Or the door's just broken, or there's straight up no lock. Yeah. And sometimes you don't even need to find a door. Here's a good security fail we saw. It's a ladder going up the side of a building, very secure. It's got a cage around it, right? No way you could get around that. But look at the back. Hey, there's a ladder on the other side that you could just as easily take out. Let's say you've got a fence that you're trying to get around. Hey, maybe there's a tree growing in the fence. I was at a site a couple of weeks ago, and there's a huge mound of snow right next to the fence line. Just as easily climb that mound of snow, climb over the fence. Ducting, where does it go? I don't know, it could be interesting. Drop ceilings, we're kind of getting into, serious coordinated heist stuff, but, oftentimes, even if there is a door, maybe the drop ceiling allows you to bypass that altogether. What could you do? Drywall, maybe? That'll be a pain in the butt to fix, mind you. And that concludes the presentation. The bottom line is it comes down to tolerances and precision, right? The security engineers, when they were designing the doors, were real smart. And then it comes down to, the fact that it's such a pain to install these things properly. So keep an eye out. Think about some of the remediations. Give it a try in your home. We have demos in the village area. You can come talk to me if you've got questions. Thank you all.